Hey everybody, I thought I would create a screencast that would help you, um, as opposed to just reading the example that has been assigned to you on present value. I thought this might be a good way to help shed some light on the topic and help you to decipher what's going on. Okay, so here's example two from the text, and it's one about credit debt. So we have John who has a loan for $5,000. Okay, so that $5,000, that's the amount he has borrowed. Okay, he wants to pay the debt off early. So the creditor, now it could be a bank, it could be some other organization, is going to discount the loan, and the rate will be 8% per year, compounded semi-annually. So how much would they be willing to accept today? All right. So up to this point in time, you've worked with the following formula. So the amount is the principal multiplied by 1 plus I to the n. So we're going to utilize the same formula, but we're going to actually change it in such a way that it makes it easier for us to solve this type of question. So what you can see here is that we already have some specific values. Okay? So right now we know the value of A. So that's how much he has to pay back. We do know the value of I. It's given as 8% per year. That's here. The thing with the interest rate, though, is if you take a look at the compound, okay, the compound frequency is semi-annually. So we know, based on previous lessons, that the interest rate is going to be the rate, 8% as a decimal, divided by the frequency, which I think we were calling F, wasn't it? So 0.08 divided by semi-annual compound is going to give us 0.04. Okay. The n value, we know a bit about that too, because the n, that is, let's see, how long do we have? 4 years. Okay. So the n value, remember, what we end up doing is we take the time in years and we're going to multiply that by the compounding frequency, okay, which in our case was 2, okay, because of the semi-annual compound. That brings us to 8. So in our formula, what ends up happening...
Excuse me, interruption. This is a message for all intermediate staff members that there is a staff meeting in room 208, a brief staff meeting in room 208.
Is we have 5,000 equals P multiplied by 1.04 to the power of 8. So there's actually two ways we can do this. I'll show you one way, and then we'll reflect on kind of how the textbook is doing it. All right. So for us, algebraically, if we want to solve for P, and that is to isolate this variable, to get it by itself, okay, is some of the language we've used in the past when we're doing some algebra, is we need to divide out this power, okay, from both sides. So we'll divide both sides by that power. And what that'll do is it will give us the value of the present value or the principal, or in this case, what is called the discounted value. So we are going to discount the loan, and you can highlight that here. We're going to discount that loan, and that's what the P value is going to be. So we'll take a calculator. Just going to grab mine here, and we end up with, let's see, 5,000 divided by, now I'm actually going to open up some brackets because I want to make sure the top and the bottom are figured out independently, and then when I hit equals, it'll end up dividing it. Okay, so in my bracket I'll have 1.04 to power of 8. Notice how I'm using my power key, and that's the value in the denominator. Now pressing equals will then divide that into the 5,000. So I have 3,653.45. So let's record that. Okay, so that's a dollar figure. I'll just add those symbols in above. So we've answered the question. Okay? We know how much the loan's going to be discounted by. So instead of paying $5,000, John's going to pay back $36.53.45. Okay, so that's one way to deal with such a question. Now there is another way. Okay, so if this procedure, the one that I've outlined here, okay, if that's something that comes easily or it's something you've been using in the past, I would keep with it. And I would also definitely challenge myself to do as much as I can with it. But what I would ask you to do is the following. So I'm just going to clone this page and remove a few things to make some room. So let's do that. Clone the page. There it is, the clone. And I'm going to leave the calculation here. I'll take this out. We already have it, so let's get rid of that. And let's clean up the top here. Let's get rid of that for now. Okay, awesome. And what I want to focus on, guys, is this thing here. So this is a timeline. Okay. So in the timeline, what you can see, now I'm not sure where they're getting the dates from, but I think they're just using January as a convenient starting point. But if you were to count along with me here, we actually have, we have 1, 2. Okay, so there's 2 compounding periods or interest periods where you're charged interest. And then we have another 2. That brings us up to 4. Okay, so that's another 2. And then 6, and then another 2 brings us up to a total of 8. So every year, right, every year we're adding on another 2 compounding periods. And that plus 2, that relates to this. Okay, so that's the compounding frequency all the way along. Okay. What this is down here, right, that's the total. That's the end value in the formula, which we decided was 4 years multiplied by 2. Because every span of 2, that's also 1 year. So all the way along, you can see how we have 4 years, and each year has those 2 compounding periods. So a timeline is an awesome way to visualize the payment schedule, whether it's a loan like this, or if it's an investment where you're making money. So why is this important? Well, let me clone this again here. I want to just focus on the timeline specifically with you. Okay, so here we are with the clone page. I'm going to remove most of this. Let's take all this out. And we'll leave, yeah, let's take out all the markings down here if we can. And I'll leave the dollar value here just for reference, and we'll bring that back up here. Just throw that out of the way. And what we'll do is this. So remember the answer we got. That's here. That's the principal. And I remember a number of people saying to me, it's the initial amount, it's the what you are going to be putting in to earn money on, that kind of thing. So this is the present value of the principal of our loan. Whereas down here, right, this was the A value, which was the 5,000. That's what we were going to end up paying back with the interest included. So if we think about it, if we were going to move forward through our chart, okay, what we would end up doing, remember how we used to do find the growth factor, okay? So I know that the growth factor, right, is what connects those consecutive dollar values. And that is actually 1.04. And we know that, guys, because of, here it is, right here, there. Okay, So 0.04, that's the interest rate, okay? And that's what we have here. That's the growth rate of the money. So we'll use that as the growth factor. So all the way along, you would end up multiplying by 1.04 times 1.04 all the way through. 8 times you do that. Okay? And that's why it's to the power of 8. Okay? So considering that, right, what happens is that if we want to solve this question, right, how much would they want to accept from us today, that is from John today, we'd have to do the opposite. We'd have to start at 5,000 and go backwards. So divide by 1.04, divide by 1.04, and so on and so forth. Okay? So you just keep on doing that and do that 8 times. So that's the reason why we end up dividing by the 1.04. So you've never really considered, well, I just did algebra, but you weren't 100% certain why you did that. Well, that's the reason why you're dividing here, okay, is we need to, because we cannot get from 5,000 down to the principal value unless we divide it repeatedly, right? Unless we just keep dividing it repeatedly to get back to where we started. All right? So, hence the reason for this. So the amount is 5,000 divided by 1.04 to the power of 8. And that gives us this value here. Okay, that's our p-value. And my apologies, that should read p equals. Now, last but not least, the textbook, it organizes it a bit differently. Of course, it's a limited explanation. I do hope it works out for you. But if not, then this video definitely, I hope, is helpful. But you'll notice what they have written is that p is equal to the a value divided by 1 plus I to the n. Okay, that looks a whole lot like, right? Check it out. Check out the form. Very similar. Okay, these are just with numbers substituted in. But they went one step further, and they went so far as to say that it's a multiplied by. Okay. Remember what happens with powers that have negative exponents. Okay, what you can do is if you have any power which is in your denominator, any power in the denominator, you can absolutely, okay, we used to say flip it. That means to invert or to reciprocate. So you can flip that fraction around and then change the sign on the exponent. So in short, the formula for present value is this here, and that's to the minus n. So a times 1 plus I to the minus n. So you can apply that formula to any of those calculations. You can also visualize it in the form of a timeline. Okay, that would totally be a great way to do it. A third way is if you don't want to use a newer formula, you want to stick with something that you're accustomed to. Start with this. Okay, so there's so many ways to solve the same problem in order to successfully solve this financial problem.